Welcome back to the channel, guys. In this video, I'm going to be showing something that a lot of companies hold pretty close to the chest, and that is new product development. If you know Heintz FG well enough, I have come up with two different variations of caliper options for the rear of the RX7 FC. And the first one was a welded bracket that retained the OEM size rotor, OEM foot brake caliper, and then added a secondary Z32 caliper for the hydraulic handbrake. After that, I decided to offer an option that allowed you to run two Z32 calipers on each side. And in order to fit that, I had to increase the rotor size to an RX7 FD diameter rotor, and that's a CNC machine bracket. So to me, that's an improvement. Running the OEM calipers is hard because they're super hard to find. They often need rebuilt, and they're expensive. And the performance you get by running a Z32 is just a no-brainer. So in addition to those rear kits that I've offered in the past, I want to offer something for the front. And the best path forward, in my opinion, for this is to run a 350Z track edition rotor with a Z33 350Z Brembo style caliper. In my case, I'm going to be ordering Part Shop Max version of the Z33. And this is a 300 plus millimeter rotor, so very large. I'm going to try and fit this with the 17 though. And ultimately, I think this will be a really good pair to my Z32 rear caliper option. So the configuration I have set up right now is a FTF angle kit with their 350Z hub bearing setup welded on there. So when they designed this, they retained the factory caliper mounting location. So in theory, it should be identical to an RX7 FC knuckle and should work for both cases. The only difference being that the RX7 knuckle or spindle is a smaller hub diameter. So you'll have to run a hub-centric spacer. But in either case, I have both versions here, so I'll test both. But first step in new product development is we need to get all of our parts, and we need to get all of them scanned and into CAD. So I've got my assembly here, rotor onto the knuckle, and I'm going to scan this first, then I'll pull the rotor off, scan it again, and then I'll wait for those calipers to show up, and I'll scan those separately, and we'll just get everything all in CAD at once. We are back with some Z33 4-piston Part Shop Max calipers, and I've already done a fit up, and this is just how new product development goes. Sometimes you have an idea and you don't know whether it'll work or not until you get into it, and that's where we landed here. So my initial plan for these calipers was to ignore, I've got the bleeder on the wrong side, but it doesn't matter, was to try and get right in between the factory location. And my micrometer was close just by pictures that I've seen, but it's not close enough. It looks like that's got quite a bit of pad contact, but it doesn't. There's still a fair amount. There's at least 1/4 inch or more. These have to be pretty recessed in there. So I'm going to, unfortunately, knowing this, I'm not going to be able to offer this to people with a factory RX7 knuckle. If there's not enough room to mount it using the existing brake caliper mounts, you know, I'm kind of stuck. And thankfully, this is a FDF knuckle with a 350Z hub. I have a couple of extra pickup points that I can use. So I'm not, you know, completely stuck, at least for this application, but when you lose 90% of your market because you can't use an OEM knuckle, you know, kind of SOL. So I think this will probably just be a personal project now. And I have these calipers in order to develop kits for other chassis. But we're going to keep moving forward to figure out a solution since I already have all the parts for my car and see where we land. But what I'm seeing here is that I'm going to need to pick up on these two 350Z hub bolts, and the top one is very close to this wall and this weld. So that means I can't just pick up on those two. This one would have a super thin wall with bolt hole tear out risk because how close it is to that weld and how small that wall would end up being. So I can't just use these two. I'm going to need to add a third, I think just on the OEM location in between. So this is 3/8 plate. I think what I'm going to do is find the perfect middle ground after cutting off this tab for clearance to get this thing where I want it, and then end up drilling and tapping an M12 by 1.25 somewhere in here. So first step to figure all that out, where everything lands, whether I even want to come up versus coming down. I'm guessing in CAD it's going to be a lot more reasonable to bring the caliper up rather than down towards, you know, where things can possibly impact. So yeah, first step is just getting this thing all scanned up. And to save time, I'm not going to cover all of that in great detail, but my process for doing something like this that's fairly complicated, I'm not even going to spray this with 3D scanner spray, and I'm going to do it in at least 2, maybe 3 scans. First step is just positioning it to where I can see these 2 bolt holes. This is the thing I care about the most, and it's an easily identifiable feature for the 3D scanner. So I'll scan this side and capture as much as I can in one pass like this, and then export that. I'll probably do the same thing from the back side. Come from here, trying to capture up and down and over, and then if that's not enough, I'll go ahead and do maybe one more, you know, like this, where I can try and capture the overall width between the paths. And then the way that I'll export that in SolidWorks in CAD is on all 3 scans or 2 scans, I will put a boss that is located on these 2 holes on all 3 scans. Then I'll align them with that. And I can create planes on both sides here and compare that to what it physically measures out at. That way, all 3 scans perfectly align. Depending on the scanner you have, some of them offer excellent features to do all of that for you, but this is the, you know, nitty-gritty way of doing it to account for a cheap scanner. So let's get that scanned and figure out some solutions. All right, we're now over to the PC. We've got our 3D scan of the caliper loaded in, and if you follow the feature tree on the left, you can see this is scan 1. And like I mentioned, I like to work with multiple scans on something like this. It's a cheap scanner. It works better when you just take a single pass from one orientation and kind of stack your scans up rather than rotating the part around a bunch and relying on feature tracking. And I was struggling to capture it all in one scan anyway, so this is my process. So this is scan 1. I've got plane 1 here that I built onto this face, and then I built up my 2 extrudes to find the center point where I need to be bolting my caliper bracket to. And to do that, I had some subscribers let me know about this feature here, selection filters, toggle selection filters. And thanks to those folks who mentioned this, it allows you to pick up on all of the vertices on your mesh without having to use the scan to 3D feature or add-in in SolidWorks that I was previously using. And when you don't use that filter, it just pulls up as, you know, one selection box for the graphics body. So thanks to those who made that comment. So same process moving forward, scan 2, same thing, built out the boss extrudes and mated up concentricity mates on the cylinders and set the width of the caliper bracket to what I physically measured in person. And then scan 3 here, we just wanted a little bit more detail underneath the body to see a little bit more clarity on the width between the pads. So that's really it. As you can tell, Solder's kind of struggling with all of this mesh data, but we've got everything we need now to take those 2 cylinders and mate it up where we want on the knuckles. So let's get over to the knuckle scan and get that thing all loaded in. All right, let's go through this master knuckle assembly and break it down step by step. Starting with the knuckle without the rotor. My primary focus for this scan is good scan data of the hub and the front side of the caliper mounting face. In the exact same way that we did the caliper, I'm just modeling in a plane and doing the boss extrudes on center line of the holes. Very simple stuff. Second scan, I'm focused on the back side of the knuckle and capturing all this data of the back side of the rotor. And here you can see I modeled in some hexes to mimic the hex head bolts so that I could find center line of the wheel bearing mounting holes. And then lastly, I've got boss extrude 2 here. This is just mimicking, the geometry of the rotor. So we've got everything we really need here. We've got the OEM caliper mounting bolts, the hub bolts, and the rotor modeled. So that's everything we need to start creating mates. So the next step you would think is to bring in the caliper, which is what I thought, as you can see by my feature tree, but really the next best step was to bring in, the bracket itself. So here I'm creating this bracket based off of, stuff we already know. We know the distance between the hub bolts. We know the distance between the caliper bracket, or the caliper bolt holes. And so I just did an educated guess to figure out where those go. And I did them based off of, the center origin of the sketch. And so when I created this circle here, I created off of center of the sketch, and I made a concentricity mate between that face and this face so that I could keep everything concentric. That allows me to, when I put the caliper on, just keep, zhuzhing these distances over until I got proper pad contact, but the pad contact is uniform on, the left or right side because it's all symmetric and based on this concentric mate. So kind of difficult figuring all that out, but really that's the right order of things for me to get this right. Couple issues here. This one is that there's a weld right here next to the bracket, and it makes it so that this wall is super thin. And because of that, I've got a third hole that I'm adding here where I'll just drill and tap into the existing flange to try and give it some more strength. But really, that's it. It wasn't a crazy complicated process. If I hide that other scan, you can see a little bit better where I'm going to have to modify the actual knuckle to remove material. So if I show you guys the cut fixture, so the cut fixture is just something I mocked up quick to show you where I plan to cut material. So I'll 3D print that and allow me to scribe a line and know exactly where to cut so it's not too little, not too much material. And away we go. So that's really it, guys. It looks super simple. It's not. It takes some time to figure out, but this is, the broad description of what it takes to model something on a bunch of assembled scans together. So let's go ahead and get these things 3D printed and mocked up on the knuckle, because this is a solid Rev A. I think this will probably be pretty close to what we want. So let's see where this thing lands when we get actual parts mounted up. So we've got our design finished up. We've got our 3D prints printed. First step is a cut fixture. So I've got this little guy. It's pretty crude, but it should give me exactly what I need. It should be not too little and not too much clearance for the Z33 caliper. So I've got this little radius that just maintains concentricity on the bolts, and then the flange lines it up exactly where it needs to be. So I need to find an M12 for that little cut fixture first. But once this is cut where it is needed, I've got my 3D printed prototype. You can see it really didn't need to be that offset from where the OEM flange was. And you can see how tight this thin wall is. So that doesn't matter just for fit up, but it will matter for getting this thing on the road. So first step is, after that's cut, mount these onto the hub bolts. If that shows me that the caliper is positioned correctly this way and this way, then V1's done. And I'll go back and scribe my line for this third hole and drill and tap that M12 by 1.25. But it's rare that V1 works. So let's go ahead, get this thing cut up, and we'll see where it lands. So I found a bolt that fits. It wasn't actually M12 by 1.25, but this should be everything we need to get our line traced out. So that should be it. That's our cut line, and how much material needs to be removed in order to get this bracket enough clearance to move in there and position the caliper where it's needed. There it is, Z33 Track Edition calipers on an RX7 knuckle. And V1 turned out super good, and I think it's nearly where we want it. There is one issue that I noticed, and that is that the distance between pad to rotor is not equal on both sides. So we're not quite center line of the rotor. And that's to be expected. Those are minor discrepancies in the scans on the model. And if that's the only thing, that's awesome. You know, that's a super cheap scanner and real close to perfect right out of the gate. And the thing that I use to establish perfect center line is feeler gauges, and I measure the casting. So these are die cast aluminum. They're not finished machined down here where you see that light. And so they're not perfect, but that's more what I'm using rather than the pad to determine center line. I am also looking at pad, but I care a little bit more about that. And one thing that I did was I put the other caliper on this setup already, and I measured at those 4 corners and determined what the average was. So I need to move the boss on my bracket to the left 20 thou to get perfectly on center. And that's really it. I don't think there's anything else needed for the bracket unless I wanted to pick up on this OEM location. I did determine these are M12 by 1.5. The hub is M12 by 1.25. This would also probably need to be a socket cap screw. Might be kind of annoying having interchangeable thread pitch, and it's not totally necessary to have that other one, but it would kind of provide some symmetry in the design and look a little bit better. It probably wouldn't cost that much to add this little piece. So I might just go ahead and add it, especially since this is just a product for me and it's my cost, not the customer's. So really, that's pretty awesome for V1. So now we're going to move on to CNC machined, but from a design standpoint, that's really it, guys. All right, guys, that does it. This is new product development in a nutshell. Taking your raw components, 3D scanning, 3D modeling, then 3D printed rapid prototypes so that you can move on to CNC machining production. And that's a good look behind the scenes for some of the type of stuff that I do for my business, as well as for apparently personal projects. But that's the way new product development goes. Let me know what you guys think down in the comments, and let me know what other content you want to see. We'll see you next time.